Now that we know about the thyroid gland, the adrenal glands, and the gonads, the question is, how do they know how much hormone to make and like what's the right moment to release it? And that is when the hypothalamus and the pituitary gland get involved. So one of the things I'd like to share with you, um, you know, there's so much detail to know when we're talking about physiology that for myself, whenever I can kind of group concepts or generalize, I find it really, really helpful. And in the endocrine system, I find it helpful in a number of ways. But the hypothalamus and the anterior part of the pituitary gland, the hormones that they control levels of are the hydrophobic hormones. Now, not all of them. Of course, there's always an exception. This is biology. But the hypothalamus and the pituitary gland, they control how much thyroid hormone you have. They control how much cortisol you have. And they control how much estrogen and progesterone and testosterone. So these guys are the hydrophobic ones. Now, not all of them. So aldosterone, well, it's its own guy. Okay. But I just think it's good to kind of have that in mind. When they say that the hypothalamus or the pituitary gland or whatever is the master regulator of the endocrine system, the truth is there are plenty of hormones that are not regulated by these guys. The parathyroid glands are not. The calcitonin from the thyroid gland is not. The aldosterone from the adrenal cortex is not. Insulin is not. There are plenty of hormones that are not regulated by these two guys. But what those two guys do is super cool and very important for you to know. So the hypothalamus is the master regulator. You know what? I am not going to ask you that question. So, like I said, some books say the hypothalamus is the master regulator. Some people say the anterior pituitary is the master. I'm not going to ask you that question. But I do want you to know this, that the hypothalamus, this is a part of the brain. This is neural tissue. And when I think about the hypothalamus right here, when I think about it, I think of it as kind of like the NSA. You know, they say the NSA is monitoring everyone's phone and text and tweet and stuff like that. Okay. It's kind of like that. It is listening in on what's going on. The hypothalamus knows whether you've been cold or not. Okay. The hypothalamus knows how much sunlight there is and whether you're getting enough of it. The hypothalamus knows if you're getting enough sleep. The hypothalamus knows if you're worried about something. The hypothalamus knows if you lost an important match. Okay? The hypothalamus, everything that your brain knows, your hypothalamus is listening in on it. And then your hypothalamus will use that information to regulate how much thyroid hormone you have, how much testosterone you have, whether or not you're going to ovulate that semester, and whether you have a lot of stress hormone in your bloodstream. Okay, so when we say it regulates most glands, let's not be sloppy about that. That's not useful. Let's be specific that it is specifically for the thyroid gland's release of thyroid hormone, the adrenal gland's release of cortisol, and the reproductive system's release of sex hormones. Right? Now, another analogy. Oh, hey, did anyone see The Aviator? The Aviator was about Howard Hughes. This is supposed to be a picture of Howard Hughes. The Aviator is about Howard Hughes, and Howard Hughes was a super rich guy, and he was actually a very good businessman, and he was in control of an enormous company that was in control of lots of smaller companies. We're going to imagine that Howard Hughes is the hypothalamus, okay? He's the hypothalamus. And the hypothalamus is in charge of lots of stuff. seems wrong. Lots of stuff. He's in charge of how much thyroid hormone is being made by the thyroid company. He's in charge of how much cortisol is being made by the adrenal company. He's in charge of how much testosterone is being made by the gonad company. Okay? He's in charge of all this stuff. And what is he doing? He's listening in on all of this information. He's tuned into the news and the business times and reading the Wall Street Journal. He's tuned into all this stuff and making decisions. But there's something wrong, okay? The only person he will talk to is his right-hand man, this guy with the spiffy smartphone, okay? And I bet it didn't get any texting at all right? And this is going to be the anterior pituitary. The anterior pituitary is related to the hypothalamus the way Howard Hughes would have been related to his right anterior hypothalamus. I start talking and I start spelling the wrong thing. The anterior pituitary. The anterior pituitary is related to the hypothalamus the way Howard Hughes, or a theoretical weird rich guy, would have been related to his right-hand man. If the hypothalamus decides, hey, the thyroid company needs to be making more thyroid hormone, he doesn't pick up his phone and call the thyroid company. No, he tells the anterior pituitary, and the anterior pituitary tells the thyroid company. And the thyroid company, the thyroid gland, is used to this. The thyroid gland knows that it never gets direct messages from the hypothalamus. It knows the hypothalamus is in charge, but it knows it never gets direct messages. And so whatever the right-hand man says, that is what the thyroid gland does. Okay, that's it in a nutshell. Let's walk through the details, okay? The hypothalamus is a part of the brain. It's neural tissue. The pituitary gland, we're talking about the anterior part right now. The anterior part is glandular epithelium, and the anterior part is in charge of the thyroid gland, the adrenal cortex, and the gonads. Okay? Here's my girl again. Would you stop? Okay. So, to your hypothalamus, your perception of your experience is your reality. All right? So, here's my hypothetical story. We have got these fellows over here, and they are out for a day at Six Flags Magic Mountain, and they love roller coasters, okay? Every time that they get a chance, they will go to Six Flags Magic Mountain and they will ride roller coasters. And they're going to ride 6 roller coasters that day. They love it. And during that day, they're going to have significant G-forces, lots of wind in their face. They're going to be waiting in line. They're going to be hearing people screaming. They're going to be hearing people laughing. They're going to throw their hands up in the air like they just don't care. That's going to be their day. And because they love roller coasters, at the end of their day, not only will they be calmer, but they will be more closely bonded to each other because of a hormone called oxytocin. And if I take some of their blood, I would find that their white blood cells are better at killing cancer cells and better at killing off viruses. Mark, could you get the and on the other hand, let's look at this little guy. If this little guy was at Magic Mountain on the same day as these fellows, and he had to ride 6 roller coasters that day, he would face exactly the same reality. His reality would be the same. He would have the same G-forces. He would hear the same laughter. He would hear the same screams. He would have the same wind in his face, right? However, he hates roller coasters. So because he hates what's going on, his perception of his reality is different. And that would make all the difference in the world. These guys over here, their hypothalamus would tell their body, make less cortisol, make more oxytocin, make more testosterone, right? This guy's hypothalamus would say exactly the opposite. So at the end of the day, his white blood cells would be worse at killing viruses and killing cancer cells than they were at the beginning of the day. It's kind of not fair, right? But if whatever your reality is, if you're dreading it, then the hormones in your body change and actually in the modern society make the situation worse. And that's because this whole setup, it did not evolve in modern society. It did not evolve in a period where we deliberately go on roller coasters, right? It evolved when chronic stress was starvation. Now, chronic stress is studying, exams, being locked up because of COVID-19, a boss that's being a jerk. That's our chronic stress, right? So it's not adapted for this environment. All right, let's talk about it in detail. So here's your hypothalamus, this area right here, right? Your hypothalamus has got lots of nerve cells, and they are listening in. We listen in on what's going on. My boss is being a jerk. I've got an exam due. I haven't been studying. I don't have time. Haven't been getting enough sleep. The hypothalamus is listening into all of that. And the hypothalamus makes decisions based on how you feel about all of that. If you feel challenged by what you're confronting and you're excited about it, your hypothalamus will go, oh, excited, let's do this. If you are dreading it and it's awful and you just feel doomed, then your hypothalamus will go, oh, let's do this. Okay, not fair, but it's the way things work in the hypothalamic world. Okay, so the hypothalamus has got different cells, and those different cells in the hypothalamus, there are lots of nerve cells in the hypothalamus, but the ones we're talking about are called neurosecretory cells. They're called neurosecretory because, like any other nerve cell, they release communication molecules, but unlike a typical nerve cell, the molecules they release do not go into a synapse, they go just into the bloodstream. And the blood stream that they go into is this area right here, which is called the hypothalamohypophyseal portal system. Oh, there you go. Hypothalamohypophyseal portal system. It is a minuscule little tiny capillary bed, super tiny, okay? There are only a few drops of blood in it. And so even though these cells only release just a few little molecules, they go into such a teeny drop of blood that the concentration of those molecules is significant. And that blood goes immediately here to a second capillary bed, which is in the anterior pituitary, okay? Now, the anterior pituitary has got lots of different cells. It has got cells that make growth hormone. It has got cells that make hormones that will stimulate the release of estrogen and progesterone. It has got cells that will cause the release of a hormone that will stimulate the thyroid gland, okay? So it's not a whole bunch of cells of the same type that are releasing different things. It's got different cells that each are target cells for individual hormones being released by the hypothalamus. So let's imagine this is a neurosecretory cell, and it is the one that says, hey, it's super cold right now. Let's warm up our body by making more heat with our mitochondria. We need more thyroid hormone. So reclusive rich guy says, hey, right-hand man, I need more thyroid hormone. Will you see to it? Reclusive rich guy is going to send out its hormone, which we'll talk about on the next slide, and that will go here, and it will find just the cells that are target cells for thyrotropin releasing hormone. Thyrotropin releasing hormone will cause that cell to release thyroid stimulating hormone. Thyroid stimulating hormone will be the anterior pituitary's way of sending out a signal that will find its target cells only in the thyroid gland. The thyroid gland will be the only set of cells that have got a receptor protein for thyroid stimulating hormone. And the thyroid gland will go, hey, the boss's head dude says we should make more thyroid hormone. The thyroid gland will make more thyroid hormone, right? That's the way the system goes. So we will start the next video with a quick review of this concept.